Hi everyone. Hi everyone. Good evening. Hi Miss Anas. Okay, so welcome to another exciting YouTube live. So my name is Nida Sheikh. Thank you, Adil sir. So my name is Nida Sheikh and I'm a STEM educator from Tan90. Today we are going to build something very interesting, simple and smart device, that is the rain alert system. So this rain alert system will automatically gives an alarm when it rings. So we'll wait for a few minutes to let people join. So for the one who have already joined the session, I would like to give up a questions like which of the state in India is highly prone to flood. So you can comment on the chat box. I repeat my question: which state in India is highly prone to flood? So you can write your answers in the chat box. By the time we will wait for the rest of the people to join, the ones who have already joined can write the answers in the chat box. So I repeat my question that you need to write in the chat box which of the state in India is highly prone to flood. You can write your answers in the chat box. Can we have few answers in the chat box? Okay. Am I audible? Saying no. What is happening? Okay, now is the video and audio. Okay, thank you. So I'll just show you all the steps again. So we have taken a second board, and we have cut 3 aluminum strip, aluminum foil, and we have stick them on the board like sunboard in a straight line, and it is parallel to each other. Okay, so we have left a gap between them, each strip, and it is very important to see that the strips doesn't stick to each other directly. Okay, and we have used the tape at the end, and we have not covered the middle area. We have kept this middle area between each of the strip open. All right, so I am placing the strip on this plastic this. Okay, can somebody type on the chat box like why do you think we are leaving the gaps between the foil strip? Why is it important? Okay, so the gap is left because water will fall and it will act like a connector between the strips. So it is important to leave the gaps between each of the strip. All right. Okay, now we are going to connect the component one by one. Okay, so first we are going to take battery. I'm attaching the battery clip to it. Okay, I'm moving this little bit behind. So I'm placing the battery here. I'm placing the battery with the double-sided tape so that the battery sticks firmly at one end of the cardboard. Okay, so we are going to first connect this positive wire of the battery with the switch. Okay, so here is the switch that I'm taking, and I'm connecting this positive wire with the switch. All right, from the other end side of the switch we are going to connect a wire to foil strip 1. Okay, so if you can see here, so I have attached my positive of the battery to the switch. Okay, and now I'm connecting the other terminal of the switch to foil 1. So let's consider this as foil 1. Okay, I'm considering this as foil 1. Okay, this I'm connecting to the terminal, other terminal of our switch. So whenever we turn on the switch, this foil one, that is strip 1, will get a positive power. So till here, is it understood? Can I get a thumbs up on the chat box, or any emoji that you like? Is it clear till here, the steps? Okay. Now I'm taking a transistor. This transistor is BC547. Alright, you can see here it is written. So here it is written BC547 transistor that I have taken. Alright, so the next thing that we are going to do is the negative wire of the battery. So the negative wire, that is the terminal of the battery, we are going to connect it with the emitter of the BC547 transistor. Alright, so this we are going to connect the battery, we are going to connect with the emitter of our transistor, and the transistor that we have taken is BC547. Alright, please be careful and please see that you are using this transistor only in BC547. Alright, so we have to keep this transistor in this manner, that the name of the transistor is written on the front. So we are holding it in this manner, and we are attaching the emitter at one end of the transistor, that is a negative Alright, so here we have connected one, and the next step is now we are going to see foil strip 2. Okay, so we have considered this as foil strip 2. So we are going to connect one of the wire from foil strip 2, and it will be connecting directly to the base of the transistor. Alright, so let's connect that. So I'm taking another wire. Okay, so this will be getting connected to the base of the transistor. Okay, so as you can see here, so this is the base, the middle of the transistor. This is the base. Alright, so this foil strip 2 will be connecting to the base of the transistor. Alright, so now we are going to connect. Yeah, catch this. Now we take buzzer. Alright, so this is our buzzer. So this is the positive end of the buzzer, and this is the negative terminal. Alright, so we are going to connect the negative terminal to the other end of our transistor. So negative terminal we are going to connect like this. We'll place buzzer here. Okay. So now we are connecting the negative end of our buzzer to the collector of our transistor. And the buzzer, positive side of the buzzer will be getting attached to the positive side of our battery. Let it up. All right. So we are connecting it with the battery positive. And then attaching again to the other end of terminal of our switch. Okay. So now we are going to stick this so that it is getting firm little bit, the switches and all. I'm connecting, putting a double-sided tape and making a switch so that it is stuck firmly. All right. Transistor, buzzer, everything is connected. So now you can see that the foil is dry. So do you think the buzzer will ring? You can type on the chat box. If the foil is dry right now, I have not put anything. Do you think the buzzer will ring? Adil sir, you said yes. Okay. So, okay, right now I'll just put the switch on and let you know is it ringing or not. All right. So, can you hear anything? Any sound of the buzzer? We haven't poured water yet. So, do you think? Okay, maybe. All right. So, no, the water, if there's no water, the strips are not connected. As I've said prior as well, that we are keeping space between the strip. If you are not keeping the strip space, then the circuit will be a closed circuit. All right. Now it is. You can see here it is an open circuit because we have left a space between them. All right. So no electricity will go to the base of the transistor, and the transistor remains off. So the buzzer will not get a complete path, and therefore the buzzer will remain silent. All right. Now what you have to just imagine. Okay, yes, thank you for the curiosity. I will, the next step is to put the water on the foil. Okay, yes, as correctly guessed. So we'll just imagine like it started to rain. So what do you think? What will happen to the foil? Okay, I'll just pour the water on the strip and see. Can you hear the sound of the buzzer? If yes, do comment on the chat box. If you can hear the sound of the buzzer, please do comment on the chat box. Okay, so now the switch is on. Okay, So I've put the switch off right now. So why do you think what has happened to the foil strip? What has happened to the foil strip? I'm putting the switch on. You can hear the sound of the buzzer. But before that, I haven't put the water, so the buzzer was not ringing. So now what has happened to the foil strip that the buzzer started ringing? Can you just guess it out and write your comments in the chat box? Why do you feel that the buzzer is ringing? Any idea, any guesses that you can make? You can write, put your answers in the chat box. Okay, when you put the switch on, the strip 1 that we have considered this side gets a positive voltage, and when the water falls on the foil, this strip, water becomes a bridge between the strip 1 and it passes through strip 2. Okay, so the small current flows into the base of our BC547 transistor, and the transistor turns on, and that is why we get a full path, the buzzer get a full path from positive to negative, and that is why you can hear the loud noise of the buzzer. All right. Oh, sorry. Okay, now I have one more question. Okay. Now I have few questions like, do you think does the water really conduct electricity by itself? I am pouring water. What I have done is just pour the water, and you can hear the sound, buzzer sound, loud buzzer sound. All right. So, do you think the water is responsible for conducting the electricity by itself? Is it the water only? If you think it's water, give a thumbs up. If you don't think that water is not responsible for that, give me a thumbs down. Okay, if you feel that the water is responsible for this conducting of electricity, give me a thumbs up. And if you don't feel that water isn't responsible, then you can give me a thumbs down. Can I expect few answers in the chat box? Either thumbs up, thumbs down, something. Okay, so if I would like pour the pure distilled water. Okay, we'll keep this question aside, like for thumbs up and thumbs down, this one. Okay, I got a thumbs up. So yeah, Raj has said that it is water that is responsible, that is conducting the electricity, and nothing else in the water. All right. So okay. Then do you think the pure distilled water will give a loud sound of the buzzer if I pour a pure distilled water? Okay, so here the fact is that pure water does not conduct electricity well, alright, but the water we use daily, so the water that we use daily has the normal tap water or the rain water that we get, it has some amount of salt or minerals dissolved in it. Okay, so the reason behind is, yes, we are pouring water here, and that is the reason that the strips are getting like power, like there's a medium of electricity to pass through water, but there's a salt that has been there in the water, and the tiny charges, it splits in the water, the salt ions get split, and it forms a tiny small particles. Okay, so this is responsible for the movement of electricity. All right, so it ions act like a bridge that helps the electric current to move. All right, so this same principle is behind the rain sensor, soil moisture detectors, and irrigation systems. Alright, so now I have a question like what is actually helping electricity to pass? Now I think it may be clear, like what is actually helping, the water or the salt in the water?